Hello everyone. So let's understand ETC in a very easy way. So it's not every time confusion, it's every time clarity or clear. So first of all, how many complexes do we have? Total 6 complexes. ETC 3 letters into 2 6. So here the number 2 and 4 will help us a lot. Remember. So 6 complexes total, 4 immobile and 2 mobile. 4 divided by 2. Okay. 4 immobile. Many people like to sit and 2 people are just rushing here and there and working. So 2 mobile are there. Just let's remember the name of those hardworking people. Ubiquinone and cytochrome C. So first of all, let's understand with this help of a story. It is a story of business basically. Ubiquinone is the central trader of hydrogen. Hydrogen is something which is made in, we can say it is grown in farms. So the first and second, these are two farmers, we can say. Okay, these are two small traders, and ubiquinone is a big trader. Through many cycles, citric acid cycle, so that cycle we are having NADH or FADH. Those are bringing hydrogen from those farms and giving it to 1 and 2. So NADH, FADH will give hydrogen to 1 and 2. NADH to 1 and FADH will give it to 2. So ubiquinone will take hydrogens from these small traders 1 and 2 and collect itself. When ubiquinone is full of hydrogens, when his godowns are filled with hydrogen, we can say it is itself reduced to ubiquinol. Just point that ubiquinone, it's ketone, and when it is reduced, what will it form? Alcohol, ubiquinol. Okay, so ubiquinol is formed here. Now next we will have, if it has so much of hydrogen, we need to transport electrons or hydrogen reduced thing in the ETC, as the name suggests, electron transport chain. Now ubiquinol will transfer it to the third thing, the third complex. But what is the benefit? Just think, what is the benefit? Here we can say a big oxidizing agent is present, that is Fe3+. Ubiquinol is saying, just oxidize me. I can't hold so much of hydrogen in my godown. I want to sell it at a good rate. So Fe3+ will take the hydrogen, will take the electrons, we can say ultimately, and will produce Fe2+. So it has taken electrons. Now 3 is also saying, I can't handle so many electrons with me. So it will again form Fe3+ and transfer the electrons to cytochrome C. I told you, ubiquinol and cytochrome C are very hard working. They will bear the stress. So ultimately cytochrome C will take the electron. Now cytochrome C, after being full of electrons, now cytochrome C has a brother. And who is that brother? From C, you can remember the element copper. And where is that present? In the complex 4. Copper is the security guard or the delivery person of complex 4. As all of these complexes are small homes, copper is the delivery person or security guard of the complex 4. It will take, what does security guard do? It keeps a check, and whenever we receive some orders or deliveries, he just takes it, and when we just want to give it to someone, we drop it at security guard and he will give it to that person, right? So copper will receive the electrons, but iron is also present here. Why? These 3 the 4 and cytochrome C. All these have a name with cytochrome. And wherever cytochrome, chrome is there, iron is there. So iron is also present in complex 4. It is a family member, right, of cytochrome. So copper will say iron is the main owner, Fe3 plus. It will receive the electrons, then it will go to Fe2 plus. Fe2 plus will again now give it to the copper. It is saying I want to pass on the electrons. I don't want it in my house. These are very negative. Just go out. So copper will throw away the electrons to now oxygen. Now it will form water. So ultimately we have transported the electrons and produced water. This was the electron transport chain. But during this chain, what is the main point that has to be noted? In the complex 1, 3 and 4 hydrogens during one electron transport chain are being transported from the matrix, the mitochondria matrix, to the intermembrane space. This is the intermembrane space and this is the matrix. I hope you can understand now. This is the matrix, and this is the intermembrane space. Okay, so we have to create a concentration gradient along these two areas. More hydrogen ion concentration should be here, okay, and less should be here for ATP production, right? That we can talk about in another video, but the main concept is here, this only. Now let's revise it very quickly. First of all, we are having 4 complexes, 1, 2, 3 and 4. So here it is a big trade going on. Ubiquinone is a large and big trader of hydrogen. So 1 and 2 are small traders. 1 will bring NADH from farms and 2 will bring FADH2. These all will take hydrogen, will harvest the hydrogen and give it to the ubiquinone. Ubiquinone will be reduced to ubiquinol as it has to, because hydrogen will reduce as it is very negative. Okay, so ubiquinol will say that I can't sustain such negativity and it will transfer to the third complex. Iron is the family member of cytochromes. Third, cytochrome C, and fourth are the mainly cytochromes, and iron is the family member of third and fourth. Third is cytochrome B, C1, Fe3 plus to Fe2 plus, and then ultimately to cytochrome C. Cytochrome C will give it to the fourth complex. Here I told you the C is here, so copper will be there. Copper is the security guard. It will take the electrons, give it to the main owner Fe3 plus, then Fe3 plus to Fe2 plus, then it will give to the security guard again copper, and copper will give it to the oxygen. I hope you remember this in a very easy way. If you will watch this again carefully, I am sure you will be able to understand. If you like this video, then do subscribe, like and share.